Question number 41. How does sunspot activity and solar flares affect the high-frequency radio transmission? Okay, na ganito. Again, this involves ionosphere. Sabi natin, ang ionosphere kapag ka mataas ang ion density niya, the more refraction it will create for a signal. So if coming from D, it's not refracted that much, it will be refracted on E. And if not, it will be refracted on the sporadic E, which is likely to happen whenever there are solar flares and sunspot activity. So pagka na-reflect siya, magkakaroon ka instead of absorption, instead of attenuation, yung signal mo at a high frequency will be reflected back to Earth. Meaning to say, it will have an enhancement. So letter A is the correct answer. Mas lalo pang ma-enhance. In fact, yung mga nag-radyo using VHF ay tuwan-tuwa yan kapag ka merong sporadic E, which is more likely, as I have said, will come by whenever there is a sunspot activity or solar flares or even during summer times. Okay, so maganda yung communication na i-enhance because of that. Number 41. Number 42. An antenna that has no front, back, or side lobes. Walang front, walang back, walang side lobes. Sorry, iba naisip ko ron. Anyway, wala daw front, walang back, wala ring side lobes. My goodness, anong klaseng radiation pattern ito? Ang tawag mo dyan, omnidirectional antenna. Siyempre, yung omnidirectional antenna, isang buong bilog lang yun. So, walang front yun, walang back, walang side lobes. Usually, ang meron lang front, back, side lobes are basically unidirectional or bidirectional antennas. Question number 43. Impedance at the center fed half-wave antenna is blank and blank at the ends. Okay? So, center fed half-wave antenna. So, ano ba itsura niyan? Ang itsura niyan, kulay pink na naman. Default siguro talaga na kulay ito. No? So, half-wave, ulitin ko lang. No? Ayan. Ito yung half-wave natin. Okay, gawin natin blue. Favorite color ko, blue. Ayan, alright. So, ito yung half-wave antenna natin. Ang sabi natin sa half-wave antenna, what will be the impedance at the center and what will be the impedance at the ends? So, sa ends nito, ano ang voltage niya? Ang voltage niya ay maximum. I mean, ang impedance. Ang impedance niya ay maximum at ang impedance sa center naman ay at minimum. Okay, so maximum at the ends, that would be the impedance. And of course, at the center, minimum naman ang impedance niyan for a half-wave center-fed antenna. So the answer for this obviously is letter A. Minimum at the center, maximum at the ends for number 43. Okay. Next number. Number 44. Linear half-wave dipole operates at frequencies above. So linear half-wave dipole operates at frequencies above letter D, 2 megahertz. Kasi yung 2 megahertz pababa, basically that is for the quarter wave, which is basically a surface wave propagation. Okay, but for linear half-wave dipole, that is above 2 megahertz. So letter D. Question number 45. The current loop of the standing wave can be raised even further and improving radiation efficiency even more if. Yan. So, paano raw natin may improve yung radiation efficiency even more? Okay. So, radiation efficiency can be raised by using a top load. Okay. So, letter C is not the correct answer because the question is even more. Okay? So pag naglagay ka ng top load, you improve the radiation efficiency and the current loop of the standing wave can be raised even further. Ang tinutukoy niya kasi dyan, ganito, no? Ito yung physical antenna length mo, no? Pag naglagay ka ng top load, what will happen? Mangyari, magkakaroon ka pa ng additional distance for the current loop at the end. Nakuha? Okay, so na-improve yung yung distance mo, no, by using a top load. And at the same time, improving its radiation efficiency. But, sabi niya, even more, if, yan. So, ang sagot dito is, if you place not just a top load, but a flat top load. That's the effect of a flat top load. Okay, so the answer for number 45, letter D. Next question, number 46. Typical efficiency of a parabolic antenna is? Typical efficiency, that would be, that is actually a range, no? That is from 50% to 70% efficiency. Okay? Pero hindi naman kasi, kaya tinatawag ito na efficiency because not all of the power coming from the primary or the energy coming from the primary antenna will illuminate the parabola. Some will be magli-leak out, no? Some will go on other direction other than the straight path going to the receiver. So meron talagang efficiency. And typical efficiency is usually 55%. That is letter D for number 46. Next question, number 47. What is the transmit and receive carrier frequencies for amps channel 3? Okay, for the advanced mobile phone system, and it uses channel 3. Now to solve this, we use the equation 0.03n plus 825. Now there's a condition. If this equation can only be used if the channel number is greater than or equal to 1 and less than or equal to 866. So pasok yung 3 dyan because 3 is greater than 1 and less than 866. So pwede natin gamitin equation yan. What if it doesn't fall on that channel from 1 to 866? Ang gagamitin nating equation will be 0.03n minus 1023 plus 825, this equation. And that equation will be used if the number of channel is 990 to 1023. Okay, so obviously ang gagamitin natin is this equation and then substituting the value here. So this will be 3, okay, plus 825, you get the transmit frequency. In order to get the receive frequency, all we need to do is add 45. That should be in megahertz. Okay, 45 megahertz. Ang tawag mo rin dyan sa 45 megahertz na yan is the duplex distance. Meaning that is the separation between the transmit and receive frequency in amps. At yan ay lumabas sa board exam nung nakaraan. Okay, so the answer for this question, number 47, if you have calculated it, that will be 825.09 megahertz. That's the transmit. And the receive, it is 870.09 megahertz. That's the receive. So letter A, number 47. Next question, number 48. What is the angle of inclination of an equatorial orbit? Pag sinabi nating equatorial orbit, the satellite is orbiting right above the equator. Okay? So, nag-orbit siya sa equator. And the equator is the reference for the angle of inclination. So, therefore, if it's rotating on the reference itself, that will be 0 degrees. For number 48, letter D. Number 49. Earth or global beams of satellite antennas may cover Earth's surface up to what? Ang Earth or global beams can cover, like for example, the geosynchronous satellites uh, are using Earth or global beams. So they can cover up to how many percent? Up to 42% of the Earth's surface. Number 49, letter D. Number 50, when visible light or high-frequency electromagnetic radiation illuminates a metallic surface, electrons are emitted. Ano daw ang tawag doon sa law na yon? That law is actually, this is together with Einstein, but it's not called Einstein's law. This is what we call the Planck's law, letter C. And this is used in the theory of light. Okay, the Planck's law. Number 50.